Welcome to Math with Michelle, where math finally makes sense. Whether you're tackling high school math or diving into college algebra, I'm here to break it down step by step with real examples and zero stress. From algebra to functions, graphs to equations, I've got it covered. Hit that like button and let's master math together. Thanks for learning with me here on Math with Michelle. If this helped, give it a like and don't forget to subscribe for more clear and simple math lessons. Got a question or topic you want me to cover? And drop it in the comments. Until next time, keep practicing, stay curious, and remember, you've got this. Welcome to lines tangent to a circle. So as you can see here, I have a circle drawn. And we know that we can draw a radius anywhere we want. So here's a radius, and here's a radius. Okay, and we know those are congruent. But what is a tangent line and how does it reflect to the circle? Well, a tangent line is any line perpendicular to a radius. So I'm going to kind of cheat here with my perpendicular. I've lined up this. I know it's got a right angle in it. Make sure it goes through correctly. Now I can extend it now that I have it started. Okay, so we'll bring that on up. So right here, I'm going to name this point X. X is the point of tangency. Now, could I have drawn a different tangent line perpendicular to this radius? Absolutely, I could have. So a tangent line intersects the circle at exactly one point. So a tangent line intersects the circle at exactly one point. And C to X is the shortest distance to the tangent line. That's like as fast as I can get to that line X. Now, I could extend this. We'll call this here Z. And we could extend this out. Got up into my little title a little. And we can call that Y. So now we can see a right triangle formatting. And we can use all of our information about right triangles from this point on. Okay? Now, we know that if I draw that right triangle, the hypotenuse would be the radius plus zy, whereas this would just be the radius, and we'd have perpendicular however x to y is. So we know that this is longer than the radius because we had to go outside the circle to get to it. So if AB is tangent to the circle, it is perpendicular to the radius. Whoa, ran off the page. If perpendicular to the radius, then tangent to the circle. So we can keep that in mind. All right. So that would be your statement about line tangent to the circle. That's your definition of a line tangent to the circle. It goes forward, it goes backwards. So I just have another circle drawn here. Okay. And we are going to draw a quick image. Okay, so we have a picture drawn here. And we're going to ask a couple questions. So first question is MP tangent to circle N? Okay, well, let's solve for it. We know 58 plus 33 plus angle M has to equal 180, right? And if I subtract the 58 and the 33 over, I find out that M is 89 degrees. That's not quite 90 degrees. So no, MP is not, no, we'll just go, no, MP does not meet the radius at a 90-degree corner, so it is not tangent. Now we even have an explanation in there, right? Almost a little bit of a paragraph proof. Okay, what about if or given LK is a tangent line? What is K to N? Well, let's draw that triangle. What they just told us is because LK is a tangent line, L is a right angle. And they've labeled K to L as x plus 5. But how long is L to N? But you can't see what I'm doing. How long is L to N? Well, they've given us to 9 right here, which means it's a radius. The radius is 9. And we know that the hypotenuse of our triangle is the 9 plus the x minus 1, or x plus 8. So how can we solve for x? If you use the Pythagorean theorem, you're absolutely correct. Leg squared plus leg squared equals hypotenuse squared. Remember, save the animals. Don't make that mistake. If you watch my videos, I reference a couple memes about saving the animals. You don't want to kill any puppies. So make sure you actually square this binomial. When we subtract our x squareds from both sides, they cancel out. Here we'd have 10x plus 106 equals 16x plus 64. So that would give us 6x equals 42 and x equals 7. Did we answer the question? What is K to N? Well, K to N was going to be our x plus 8. So no, we haven't answered it. We only have x. So K to N is going to equal x plus 8 or 15. Which makes sense because it should be longer than the radius. Okay, so I went ahead and popped a circle up here. All I've done is draw a radius in 2 different spots. And it really doesn't matter the length of the radius. We know that they're radii, so we know that this is congruent to that, right? Well, what happens if I draw segments like 2 tangent lines? Okay, so I'm going to come in here. I'm going to draw a tangent line with my little speed square. I'm going to come in here, and I'm going to draw my tangent line with my little speed square. And it looks like they're going to meet. We'll call the point they meet A. Now, let's draw another one where they're wider apart. So let me get a new circle in here. Actually, we'll put on Okay, made them wider apart. Speed square. And we'll call this W. Okay, both times I did 90-degree corners, right? Perpendicular, perpendicular. And if I were to draw this little line right down the middle, connecting these, we have a right triangle. They share the hypotenuse, and one leg is congruent. Hypotenuse, leg. Draw the line down the middle. They share the hypotenuse, hypotenuse, leg. These two triangles are congruent, which means that this side now matches this side. Or in this case, this side matches this side. What shape do we have? If you said kite, you remember your rules very well. So when we have two tangent lines meeting somewhere, the shape they create with the radius is a kite. So I'm going to come up here and just go, if AB is tangent at B and AC is tangent at C, then AB is congruent to AC. And we can get that by drawing the line down the middle, which would be the hypotenuse, and using the hypotenuse leg theorem to prove it. So that's kind of a nifty little check-in point. So now we can see how we can utilize a circle to help us draw a kite. Okay, so I took a moment and went ahead and drew a little circle here, and we're going to label the points of tangency. X, Y, Z, and W. And we're going to name the corners of the shape A, B, C, and D. Then I'm going to give you a little information. This is 5 units long, 4 units long, 13 units long, and 8 units long. This is a point of tangency, point of tangency, point of tangency, and point of tangency. Find the perimeter of ABCD. Okay, so that might seem like a lot, right? But keep in mind that if we were to connect from here to here, because of the hypotenuse leg theorem, this triangle here has to match this triangle here, meaning we have a kite situation going on. And so therefore, if this is 4, this is 4. So see our kite right here? 1, 2, 3, 4 sides. So properties of those kites apply. Since that's 13, this is 13. Since this is 8, this is 8. Since this is 5, this is 5. We just had 4 kites. And once we see it as 4 kites instead of a bunch of random lines, it makes it easier to see the congruency. So all we have to do is 4 plus 5 plus 5 plus 8 plus 8 plus 13 plus 13 plus 4. Okay, well, we'll start right here. 4 plus 5 plus 5 plus 8 plus 8 plus 13 plus 13 plus 4. 60. And in my original problem, I believe I had a label. So we'll call them in centimeters. So the perimeter of quadrilateral ABCD was 60 centimeters. So not really a big deal. We can use that. We can use all of our information about kites. That's kind of really the big point behind this. The other point is, how do we construct this stinking tangent line? Okay. Well, first, draw a circle. And I had to give it a name for the inside. Ooh, come on, focus. And this is how to do it correctly, not with a speed square like I've been using. My little compact mirror is not the proper way to do it. Okay, draw a circle P. And we're going to draw a radius. Come on, focus. Maybe if I... There we go. Draw a circle P. So step 2 is going to be draw a radius that extends past the circle. And we're going to call this radius PT. Okay. So my radius needs to extend past. All right, there's PT. 3, label A, where PT meets circle P. Done. Okay. 4. With center A, make a small circle at A. Not even a small circle. Small arcs. Small arcs to the left and right of A. Okay, what do I mean by that? Because that was like a really bad way of saying that. We're going to make this smaller than you had it before, not bigger. Shrink this puppy down. You could make the entire circle around A, but that's extra. We really just need to know, if we were to make a circle, how far would it go each way? We don't need the full circle, we just need the marks. Okay, now we're going to use these marks to construct a perpendicular bisector. I'm going to call this X and Y. So step 5 is to draw a perpendicular bisector to XY. So make your compass a bit bigger. Above Y, actually we'll just do a half circle. From Y, a half circle. From X, we get that little football shape in the middle. Find a straight edge of some kind and connect it. And now we have a tangent line. So you don't actually have to cheat it out and use a speed square. There's a proper way to do it. So some books teach it differently. Some online points teach differently, but that's kind of the proper way to do it in one way or form. Just extend that radius, make a mark to each side of where it meets the circle, and then you can do a perpendicular bisector using these. So yes, the speed square works for whenever you're just drawing pictures for reference sakes, but if you actually have to construct it, then it's always a good idea to understand how to do that.